In this lesson, I'm trying to show students how to look at the spread of the data using different tools of statistics. And so we start off with something that they're familiar with in the warm-up, which was interquartile range and range. So they had to find the range of the data set starting off, which was the maximum value minus the lower value. So we had 90 minus 52.7, and that gave a range of 37.3. And then the interquartile range, they had to find the median of the data set, which was 77.7. That split the data in half, in the lower half and the upper half of the data. And then they had to find the median was 77.7. They had to find the median of the lower half of the data, which was 73.5, and the median of the upper half of the data, which was 83.5, which was quartile 1 and quartile 3. And when you subtract those, you get a range of that box. 83.5 subtract 73.5, you get 10. And then they had to use that. Well, if you take 1.5, using the 1.5 rule to check for outliers, that's where we started with on this PowerPoint in the second section after we reviewed the warm-up with interquartile range and range. 1.5 times 10 is 15. Well, if you check, and from the median, if you had 77.7 plus 15, you get 92.7. And we didn't have any data values greater than that, so there was no outliers on the maximum end of the data. But when you take 77.7 and you subtract 15, we did have, that value came out to be 62.7. And therefore, 52.7 was an outlier because 52.7 was less than 62.7. And so we didn't have anything greater than 92.7, but 52.7 is going to be an outlier. Then we went through and how do you find variance, and standard deviation is another way to look at the spread or dispersion of the data. So you take all the initial data points that I have listed in the table as x sub I, and you subtract the mean. Well, when you do that, you get... And doing this by hand helps students before they actually see the calculator just spit out an answer. It's going to help them understand why it's showing variance. So 545.36, when we're subtracting, we take the data value 52.7 minus 77.7, we get 545.36, and we get, oh no we don't, that's when we square it. When we subtract, we get negative 24.4. And then you take the next data value, 72.1, minus the mean, 77.7. And remember, you just find the mean by totaling up these data values and dividing by 11, because there's 11 of them. So we end up with 77.7 for all of these that we're subtracting from each data value. So you're going to get a negative 5. And then 73.5 minus 77.7, you're going to get a negative 3.6. And a negative 3.1. And a negative 2.9, and having this table helps them to understand the different steps. 0.6, and that I actually have a link to that in the PowerPoint, which goes through one of the websites that shows the steps of this. 3.4, 3.4 again, because you're subtracting 81, subtract 77.7 again. Actually, I think that's 3.9. 3.9, and 83.5 subtract 77.7, you get 6.4, and then 11.5, and then 12.9. And then you square those values, and that's what I'm showing in the next table column is the initial values minus the mean, square those values. So you're going to get 595.36. And when you're squaring, remember, if you square a negative number, it's still positive, so square it negative 5 is 25. Then you get 12.96, 9.61, 8.41, 0.36 when you square 0.6, 15.21 twice, because when you square 3.9, then you get 40.96. 132.25, and finally 166.41. Well, the way you find the variance is going to be represented with S squared. Since we're using a sample size, it would be sigma squared if you were representing the whole population. But since we have a sample, it's going to be the sum of all of those values. So if you add all of those up, you get 1021. And I show the formula in the link that we have in the PowerPoint. And then 1021, and then we divide by n minus 1 since it's a sample instead of n. If it was the whole population, we divide by n. So since there's 11 samples here, or 11 data values, so it's 11 minus 1, so we're going to divide by 10. And that's going to give us 102.1, approximately, roughly. Now if you want to find standard deviation, then you take the square root of that. So the square root of 102.1 is going to be approximately 10.1. So the variance, S squared, is 102.1 approximately, and the standard deviation is 10.1.